Welcome, everybody. Thanks for coming. My name is Jean-Louis Monteiro, and then I live in France, as probably you have understood. I'm going to give this talk in English today because I'm not fluent in Portuguese. So I think it's going to be better for you to understand. I've been working for Tomitribe for the last couple of years, 4 years, and we do mainly middleware stuff. We are like heavy contributors on the Apache community and other open source contributions, communities, let's say. And we do also work on an API gateway to secure microservices, and that's the reason why I've learned a lot of things regarding security, and I would like to share some of them with you today. I'm also an Apache contributor for quite a long time on many open source projects like TomEE, which is the one I'll be using today as the MicroProfile implementation, but also a couple of other projects. And I'm also involved in the MicroProfile specifications like the MicroProfile config, MicroProfile JWT. And when I have a bit more time, I'm also trying to contribute to the specifications. So I've been working on EJBs. I know it's quite old, but I'm old as well. And I'm going to take the lead of the next Java security API on the new home, which is Jakarta and Eclipse. Yeah, today I'm going to be focusing on the microservices. I know it's not the purpose of this talk. I'm going to give just a few words about the microservices. There are a lot more talks at QCon and other conferences, so I won't spend my time on it. And then I'll give a quick tour about the security options that I've seen so far on companies. And I'll be focusing mainly on the OAuth2 and OAuth2 with JWT tokens, because that's the purpose of the MicroProfile JWT. And I've prepared a small application, which is the movie fun application, where I basically leverage MicroProfile JWT. And I'll be using TomEE as the app server and the implementation. All right, so microservices for the young people, it's a brand new thing, brand new buzzword. For older people like me, it's nothing else than SOA, with a different name. It brings the same solutions, it brings the same issues that we have to solve. How big is a microservices? Is that a tiny microservice or a bigger microservice? So the same issues happened. And what we're going to be focusing today is trying to see how we can secure those microservices. So just a quick recap. Previously we were used to have like a couple of components with a different size, that we were used to put together inside a system, an application. Which I've called in this diagram monolithic application. And then when we wanted to scale that whole application, well, it was quite easy. We just take the same application, we just replicate it a couple of times, and then we can scale out our application. There are a couple of drawbacks with this design, aside from the life cycle of each component being kind of tied together, because as soon as you have to change one, you have to redo the full build and then redeploy the full thing, which brings sometimes downtime and makes the things more complex. It also tends to produce what I call the big bang deployment issues, where you have to redeploy the whole thing. On the scalability side of things, it does not provide a good way to optimize your resources, because some services might be used much more than others in your application, and therefore if you replicate the full application, you're going to be wasting some resources. Anyway, the way we secure usually those applications is that we put on the front of the boundaries of the application something like, I don't know, a servlet filter if you are using Tomcat, for instance, or servlets, where you're going to be basically doing all the work. And you're going to be authenticating your user, enforcing the permissions, and then all the security context is kind of implicitly passed into all the subsequent calls in the components. So basically, when you want to secure an application or components, what you need to do is basically identify who is the caller, and then what he can do inside your application. So that's the first thing, and the second thing is the propagation. So that's it for today regarding the old monolithic architecture. Regarding the microservices, I see two perspectives. One which is the technical perspective, and the second one which is more an organizational perspective. In terms of technical benefits or perspective, I've added in the slide as much as possible buzzwords as I could, but overall it solves a couple of issues. So you can reuse some components that you can also scale differently from other components if they are used more heavily to give the overall service. You can use self-contained systems and use container like Docker in order to simplify the deployments. From an organizational point of view, I think that fits a bit better the agile methodology because it tends to help in terms of iterations and make the iterations way shorter than with big monolithics, where from the beginning to the production, it takes like quite a long time. It also works better with small teams, especially if you have some remote people, because again, the iterations are faster and the context is also smaller. And that's HR proof. On big systems, as far as I've seen in companies, we tend to have like some kind of people-oriented architecture where everyone basically wants to have his own layer on top of the components. And the fact that we get smaller microservices helps to protect against that. But again, it brings, there is always a trade-off, when you pick up an architecture or technology, and I believe that the microservices solve a couple of issues, but it also brings more challenges. And the one we're going to be focusing on today is the security one, because obviously you don't have like one single entry that you can put a servlet filter in front of. You may have different entries, and then you need to deal with the security context propagation. For all this talk, I'm going to be relying on this baseline architecture where we have like 1,000 users, sorry, doing pretty much three transactions per second. They are not like playing like crazy with their cell phone, but they are doing some work with their devices. The small squares are the iPad, the cell phone, the computer, so all their devices. We've got an API gateway at the boundaries of our company that does all the security checks and load balancing and all that stuff. And then on the back end, we have again our microservices. And let's say that to deliver our service, we have to do like 4 calls on the back end. So we're going to have to pass the security context all the way through the back end so that we can identify who is doing what. Okay, so what are the security options today and what I've seen so far in different companies? So I've seen still a lot of people using basic auth. I know it's bad, but maybe a lot of you still are still using that, right? The newcomer is auth too, even if it's quite old, but that's one option that I've seen a lot of times, especially when there is some kind of user interaction. There is also OpenID Connect, and then I've seen like the majors like Facebook and Google using JWTs because that's very convenient and that's really appropriated to store the user information and pass that in all the services. The other one that I've seen a couple of times, but which is more used in a kind of B2B systems, it's basically the HTTP signatures. Which I've called the Amazon Wave. So for people using the Amazon API, it's pretty convenient and widely used. And I've seen so far as well in-house solutions. So probably some of you also created a couple of in-house solutions to secure your APIs. And probably much more, which brings me to this very good code, and which is something that I've seen many times in companies. So the problem with the security and the standards is that you have so many to pick from that you don't really know which one to choose, basically. All right, basic auth. I'm going to be quite fast on this one because, again, you know, it's widely used still today in companies, but that's not the best choice, and we'll see what are the problems with the basic auth. So first of all, how it works? Well, it's very simple. You know, this is an HTTP message. The basic auth basically works this way. So you've got an authorization header, which the basic scheme, and then you know you've got a token at the end, and the token is basically nothing else than the username and the password, which you're gonna base64 encode. Base64 encoding is not like encryption, so obviously anyone in the middle that sees this message is able to retrieve your username and your password. So that's really something you should avoid on your systems. So if we get to our baseline architecture and we see what are the impacts of using the basic auth security option, then we can see that if our 1,000 users do like 3 calls, we're going to have our username and passwords 3,000 times per second on the network. That gives a lot of chance to a hacker to you know, to be listening on the network and be catching a couple of username and passwords. And if that happens, then you know there is no other options than you know killing your profile or you know closing your profile and then starting a new one. So it's really a bad choice. The other choice, the other you know consequence is that the LDAP, if you are using an LDAP or the database, whatever you use, they are going to have the same traffic that you have to call your API. So if you know. If the users are calling now 10 APIs instead of 3 APIs, then you're going to be increasing the load on your LDAP. And obviously, for people using LDAP, you know that doesn't scale really well. On the back end, we're going to have like 12,000 TPS. So if you don't use any security on the back end, which is bad, obviously you won't be having additional load on your LDAP. If now you want to do like also backend authentication, which really you should do, then you're gonna be like killing your LDAP because obviously you have to authenticate all the incoming traffic, and then you have to authenticate for every call you're gonna do on your backend system. How many of you really do authentication in the backend? Yeah, a few. Have you heard about the Target company in the US? No. So the story behind the Target company in the US is that basically they were not authenticating the backend calls, right? They were just doing authentication on the front end. And guess what? They got a contractor that came into their premises that you know worked on their system. And this guy went into the backend services and just started to steal a couple of you know credit card numbers, and therefore the problem didn't come from outside the company. It really came from inside the company because, well, I know all of us use contractors at some point in our company, and well, if you don't secure the backend calls and anyone can do any REST calls on the backend services, then you know it's all open to be compromised. Basic auth is also, you know, perfect to do denial of service attacks. So that's really easy with basic auth because you can make up any cryptic token that you're gonna send on the header, and then obviously as you know every call goes to the LDAP, you can fire up a couple of EC2 instances and then generate a lot of load, and then at some point you're gonna burn the LDAP and then you know you are done, no more service. All right, so one of the solutions I've seen to fix the password issue, which is you know going on the wire 3,000 times per second, is auth2. auth2 provides a couple of you know options to avoid these 3,000 times password on the network, but it brings some other issues, and I'm going to try to give you the big picture of what I've seen in the past. So the theory behind the auth2 is that instead of sending each and every time your username and password, you're going to exchange the username and password doing a grant type operation. And then you're going to get back instead a token that the server is going to keep on the backend. And then the token is going to be stored on one device. So if your device is somehow lost, your account is not compromised, no one knows really your credentials. Sure, it can use your mobile phone to do some REST API calls, but at least your profile is not compromised. One benefit of that is that if you use your iPad or your cell phone, then you can start going to Twitter. I don't know if you go to Twitter very often, but on the configuration you can revoke tokens, and then the access to this. The access from the mobile phone that you're going to revoke is going to be denied. So under the cover, how does it work? So basically, it works the same way as what we have been doing over the last 10 or 20 years, maybe. You send the username and password using a form URL encoded. The server side is going to check that against RDAP or whatever backend you have, and then is going to generate a token. The token is stored on the server side. It never leaves the server side. And then we send to the client what we call an access token and a refresh token pair. This is a blind token, okay? So you cannot reverse engineer like you could do with BasicOff, for instance. It doesn't mean anything. So, it's just a random ID that you send to the client. And then, for each and every call, the client is going to give you back this token. Okay, so we're going to do a couple of calls. We're going to send back this token under the bureau scheme, right? And at some point, what happens? Well, the token is going to expire, right? So now we've got a token which is expired, and well, we're going to need to do a refresh grant. So the refresh grant is the process to where you are going to basically exchange again the refresh token that you received the first time, and you're going to receive back from the server a new access token, refresh token pair that you're going to be storing again on your device, and then from now on you can use the new access token that you're going to receive, right? So now you can move on and do another set of API calls, and that will work quite well. So what have we achieved so far? So using OAuth2, we have been able to avoid the high rate username password on the wire, so it avoids having a man-in-the-middle attack, which is going to steal your credentials. We replaced this username password token with a blind token, which now references a state on the server side, right? And well, in essence, we have created a new HTTP session kind of thing. So for those who have been doing like servlets or web development for years, what we have achieved over here is basically the same as you have been doing for years with Tomcat, for instance. So every time you go with a login form and you send credentials to your server, what happens is that Tomcat is going to generate a JSession ID, right? And it gives you back this JSession ID that you have to send again and again, so that for every call it can go look into the map and find your session again, and then that's what we have done with OAuth2 basically. So the OAuth2 basically solves a couple of issues. It brings another set of issues, because I don't know how many of you have got some issues with HTTP session replication, but it's usually a nightmare on the server side, because if you do like multiple data centers, then you have to replicate your session on all the different servers and all the different data centers. So it brings us to the same pitfalls as we have been having for the last couple of years, which is basically a stateful architecture on the server side. Yeah, in terms of In terms of buzzwords, so I've said at the beginning of this talk that microservices are nothing else than SOA with a sexy name. So OAuth2 is kind of the same. You know, instead of doing a login with your regular formula like you have been doing for years, you are now going to do like a password grant operation, which is the same in essence. And well, you're gonna get back, you know, something very, very new, which is a token, right? Which is a random string, basically. So, you know, again, when you go and you read some specifications, you should be, you know, questioning yourself if that brings you really new solutions or not, or if, you know, really you end up by having the same issues. That's the, you know, that's the way it would. That's basically the result we would have. So instead now of sending 3,000 times your username and password, let's say that you have to authenticate once a day. So now you're gonna have like 1,000 times only the username and password. On the server side, you are not going to burn any more LDAP because aside from this 1,000 call, the next calls are going to use the tokens, right? So really, the next time you're gonna call your APIs, you're gonna send the token, and then on the server side, instead now of burning LDAP, you're gonna be burning the backend database where you have all your tokens, right? So we basically push the problem from LDAP to the other backend. You know, and now if you are using some environments like PCI, I don't know if some of you are familiar with PCI. PCI is like a set of requirements that you have to do if you store cardholder information on your system, if you do payments, basically. If you do a HIPAA kind of thing with else domain, then at some point when people are doing operations on the backend, you need to be able to say in 10 years from now, you know, who did what, basically. So the way you are going to do that is basically on the back end, you're going to be storing, you know, the token information. So when someone wants to get information about the card for the user Bob, then you're going to be storing on this service that the token which did the request is this one, right? So what happens now is that if from 10 years from now you want to know who actually did that operation, you need to be storing for more than 10 years into the database all the tokens that you have generated, right? So at the beginning, when you start using OAuth2, well, it performs quite well, you know. The database is empty. It works quite well. We don't see really the pitfalls. But this database is basically continuously growing and growing and growing. And if you are using PCI and those kind of environments, you realize that you can never really shrink the database or remove some tokens because that's basically the only way you can do the matching between the ID, the token, and the user profile, you know, the person who did the action. So this is a very bad design, and that scales really bad for securing microservices. And well, again, if we start also authenticating on the back end and we start passing the token on the back end, well, we end up by burning now the database because we have a lot of load going to the database, which becomes our new single point of failure. All right. Yeah, and at some point we're going to be, you know, burning our system and we won't be able to anymore deliver the service. So now we're going to be focusing a bit more on OAuth2 plus JWT, and we'll see what the JWT tokens really bring into the landscape. JWT tokens, it's pronounced JOT, don't come to me and ask me why, I have no idea. But for people a bit older like me, it's basically SAML, but also with probably a sexier name and really less verbose. It's basically you know, a set of JSON documents, one which is the header, one which is the payload, that we're gonna base64 encode into the header, and then we can, sign that token so that no one can really change it on the fly, or, pretend to be someone else. So we basically move from a small token, which is a random token that no one can really, extract information from, and we move to this one, which is, well, obviously way bigger, right? But nowadays, the bandwidth, the cell phones, everything, gets 4G and high-speed network. So, it's a couple of additional bytes for sure. It needs to be taken into account in your architecture if you have like a lot of load. But, overall, that brings a couple of benefits that we're gonna see right now. So, yeah, that's the detail of the JWT token. So again, it's composed of a header, which is a JSON document, where you're going to be specifying which algorithm you have been doing, you are going to use, sorry, to sign the token. You can add a couple of additional information. So there are a couple of things you can do, like send the public key if you want the people on the other side to really verify the token. And there are a couple of additional standard headers that you can use. And then you get all the payload. So the payload is basically whatever you want, right? The RFC around the JWT token has a couple of standard claims. So the claims is, a claim is basically an entry in the map. So when you use JWTs, you have a couple of standard claims like the expiration date, the issue at date, and then you get the unique identifier, and then the issuer, and the rest is basically made of. You can add any contextual information you need on your system, and put that into the token so that when you receive it, you have all the information you need to do your service. And the latest part is the signature. The signature is basically the stamp on your token that proves that the token hasn't been changed. And when you receive it, that's basically the first thing you're gonna be checking, right? So that's only the summary of what I've said so far. So yeah, as I said, it's a small change in essence because what we are generating is still a token, but we'll see that it has like a huge impact in terms of architecture. So first of all, let's do a quick recap. So when we want to authenticate using OAuth2 before JWTs, we go to our LDAP, we pull out the information, we're gonna generate the access token, right? And then we're gonna be storing on the server side the token, and we're gonna be sending the pointer. The pointer could be seen like the primary key of the token in your database, in essence. So basically, the server holds the state, and the client holds the pointer, right? Which is very close to the HTTP session and JSession ID stuff. Now with JWTs, so the beginning is the same. We're gonna query LDAP, extract a couple of information, then we're gonna build up this big HMAP, the JSON document. We're gonna assign it with the private key that we hold on the server. We don't give the private key, obviously. That's our secret. And what now we're gonna do is, instead of storing the token, we're gonna store the pointer, the ID of the token. And that ID is basically only used for revocation. We're gonna see that later. And what we send to the client is the full token. So we're gonna move the state from the server to the client by sending this JWT token to the client. So what we have now is basically the server holding a pointer and the client holding the state. And that's basically what the cookies, have been doing for years. So using JWT tokens is basically similar to using cookies, right? Aside that the JWT tokens are signed. So even if someone accesses your computer, even if there is something very bad happening on your browser, no one can really go and get the token and change the content to add additional permissions or whatever, right? So basically, OAuth2 plus JWT is kind of, cookies or signed cookies. So here is what we get now. So on the different mobile phones, we don't store anymore just the ID, the pointer. We're going to store the full token. And then obviously, so that's the process. And then obviously on the server side, we're going to store only the ID so that, you know, if you lose your mobile phone, we will be able to revoke that token. And therefore, the next time you try to come in, then you're going to be rejected. The ground process, which is the logging process, is really the same, aside that the you know, the tokens that you're going to receive are way bigger, as we have seen so far. And obviously, the calls are also very, very similar. You know, instead of sending the small token, you're going to be sending the biggest token with all the context of your user. So now, what is the difference in terms of architecture if we use again our baseline architecture? So we still have like the 1,000 authentications, right? And then, you know, the subsequent calls are going to use the token as previously. But now the big difference is that, you know, to let someone get in, the only thing we have to do basically is check the signature of the token, right? If the signature is valid, then we can let the API call get in. If the signature is not valid, then we can reject the call. The big difference is that checking a signature is like very, very fast. You know, it doesn't require any backend. You know, it's just CPU and memory, so it's easy to scale the API gateway in front because you don't really need anything but CPU. And if you use an algorithm like RSA, which is very a CPU-intensive operation to sign, but which is very lightweight to validate, then you know you are going to be very, very fast in terms of checking if someone can get in or not the doors. Let's say that we have like a very aggressive policy that says that the token expires every half an hour. You know, we're going to have to do a refresh every half an hour, and therefore we're going to be checking our backend and inserting a new token, you know, not even 1 TPS. So it's, you know, the load on the backend becomes very, very low. The good thing with this approach is that if you now really want to pass the context into the backend calls, you know, you are still going to send the same token, but it won't be adding any additional load on our database. Which means that if you have to do like many other calls on the backend, you won't be burning the database anymore. So basically what they have to do is only have the public key, right? The public key, you can give that to anyone. The one you have to really keep for you is the private one, right? So you can give the public key to all the backend services so that when they get a request, when they see the token, you know, getting in, they can really also validate the token by checking the signature with the public key, right? In terms of PCI, if I get back to this argument, that also solves a lot of issue, right? Because now, if on your logs you are storing the full JWT token, at any time, basically in the future, in 10 years from now, you can really check who did what, you know. What you really need to do is basically keep the key for 10 years if you want, but I mean, the key won't be changing very often, right? So it's like the SSL certificates. You're going to change the key like, you know, every month, every 90 days if you are using Let's Encrypt, whatever. But you won't be changing that key very often. So really, you can keep that key for 10 years if you want. But this database won't be growing because basically as soon as the token expires, you can remove the entry in your database. You don't need to keep it, right? So that solves a lot of, you know, a lot of problems. So first, this one, which is no more burning now, you know, it's a small database. You're going to be removing the tokens. You don't need to keep them forever because the token is self-contained, and the only thing that you have to keep is really the key. And now, if someone wants to, to do a denial of service attack and tries to send you a lot of tokens, then you won't be, burning your database, because what you are going to do first, again, is to validate the signature. And therefore, if you keep the private key secret and you don't give the private key, obviously, no one can really make up any tokens. So as soon as you receive the token, you're going to validate the signature and then reject the token immediately. So again, if you want to have like a denial of service attack in this kind of system, you're going to have to basically fire up a lot of EC2 instances and make up like crazy a lot of tokens, which is quite hard because again the RSA signature computation is quite CPU intensive compared to the validation, which is quite fast and not very CPU intensive. All right, that's it for the theory. Now let's get to the MicroProfile. So MicroProfile is like a new set of specification of standards which are really focusing on microservices. It started like a year and a half ago. It started with version 1, which was very, very thin, basically injection of context, JAX-RES, and everything to do JSON parsing. We are currently in the version 1.3. We have now, MicroProfile configuration, the fault tolerance, the Netflix historics kind of thing. We have JWT that we're going to see right after. We have health checks, metrics, open tracing, open API, and REST client. And we are working currently on the version 2.0. So MicroProfile is basically a subset of really the Java EE world, which tends to address all the problems in the world. In MicroProfile, we really want to be focused on the microservices problems. So who is involved? Well, we find the same people usually. So we have Red Hat, we have Payara, we have IBM, Hazelcast. So we have a couple of vendors that got together. So that really means that you won't be vendor locked in if you go into MicroProfile because there is a lot of vendors around it. What does it bring? Basically, going into the MicroProfile has proved to be very efficient in terms of changes. So MicroProfile is very thin. The objective is to have like regular releases, 1 per quarter, as opposed to Java EE, which used to be like 2, 4, 5, 6, 7, or maybe now 8 years to have a release of Java EE. So over here with MicroProfile, the goal was really to be more time to market, more like Spring, and to be really more efficient in that regard. There are a couple of implementations. I'm going to be using TomEE today. So with MicroProfile JWT, you can do role-based access control. You have like the extension doing all the token checks for you. It's a very lightweight and interoperable way to propagate also entities. I'm going to be passing on this, the goals, and I'll get straight into the demo so that we can see how it works really under the cover. All right, let's move that. So what I've done so far is I've started a small a small identity provider which is responsible for receiving all the username passwords and doing the authentication and then generating the token, right? So for that we are using one of many, one of the many providers that you can find on the market. We do create an API gateway at Tomitribe, so obviously I've used mine because I know it very well. But you can use any other, OAuth2 implementation that delivers tokens. And then I've got this small web application where I am using TomEE to secure the to run and secure the microservices. So while it's running, it's a bit small. So the application is a small movie app where you have like movies and you can add comments, and for that we are using like a REST API which is currently secured by the API gateway, and on the front end it's only JavaScript. So on the JavaScript side we basically store the access token and we send it on every request, And just before the token expires, something like 30 seconds or 1 minute, I don't remember, we're gonna do the refresh under the cover so that we can refresh the access token on a regular basis. One important thing, because the time flies and I'm getting short, there is a GitHub repo that you can look at. It's public, all the sources are there, you can run it. It has all the details so that you can grab the code and look how it is. All right. So first I'll check if it works. I'll generate a couple of sample data. Yep. I'll be opening the debugger so that you see the tokens going on the network, right? Make that bigger. Okay. Let's increase this. All right. So over here, we have a REST call, and then now we've got like the JWT token going into the server, right? In terms of users, so I've got like 3 users. So this is the API Gateway Administration interface. So I've got like 3 users. Alex has like create, update, delete permissions in it. And the other ones, they have like either, I'll make this bigger. The other ones, they have like either update, delete, or create, right? So that allows me to do a couple of things like, logging with a different user and see that the backend is actually secured. In the API gateway, we can also, and I'll be using that to deny the service, we can also check all the refresh tokens which have been generated, right? And who generated them. And then I'll be removing this token right now so that at some point when we're going to refresh the token, it will fail, right? Yes, I want to remove it. And over here, I've got my auth2 security profile, and just to show you that the access token is a 5-minute access token and the refresh token is a 1 hour. Okay. So on the movie fund now, if I keep going and I keep adding comments into the web apps, so hello QCon. So I'm going to be doing a lot of calls, and then at some point the refresh is going to happen, and as I remove the refresh token on the server side, then it's going to fail and I'll be locked off the system. I'll be doing a couple of operations, and maybe until my token, my 5 minutes token expired, I'll show you a couple of things from the code. Here I go. So the first thing you have to do with MicroProfile JWT to activate the extension is to have this logging config annotation where you put MP JWT in there. And as soon as you do that, the server is going to detect that you want to secure your services with JWT. And then it's going to check the headers and see if there is a token, validate the token, build up the security context, and do all the security checks. On the REST side of things, then it's very easy to really secure, your operations by having like the regular roles load annotation. If you want to do something more fine-grained, you have the ability to use the regular JAX arrest and standard security context is user and role if you need. The JWT extensions also allows you to basically extract claims from the token and inject that into your class so that you can use the email, the username, the JTI. For instance, if you want to use when you create a comment, if you want to track who created the comment, what was the email address, you can extract that information from the token. You don't need the user to enter again that information, right? If I go back to my movie fun web app, I should now be, okay, so this is the refresh. So it didn't work because I removed the refresh token on the API gateway. So now I get like the refresh token is invalid. But as you have seen on the JavaScript side, what I've done is basically, as soon as I receive an access token, I set a timeout that basically is going to wake up 30 seconds before the token expires. So under the cover, I can do a refresh call and replace the local token by a new one, right? And then I believe that's it for the demo. I'll connect very quick with another one, which is Nick, I believe. And just show you that if I do like delete maybe. No, so he has right to delete. So I'll be trying update. I'll remove this. And then on the server side, I get now forbidden because obviously Nick cannot update a movie. And that's because I've added on the update method of the REST endpoint, I've added the @rollTheLoad update. All right, that's it for the presentation today. I'll be around in the lobby, etc. So if you have any questions, I'm happy to answer. Otherwise, you can discuss maybe a bit more later.
Pessoal, quem tiver pergunta, por favor, levanta a mão.
Hi, Jean. Thank you very much for your really nice speech. I have a doubt about the JWT. For example, I have a fat user domain, so my user has a lot of info, and I'm using a little bit of this info in some of my microservices in the backend. So the question is, do you think it's good to load all this info in my JWT and make a fat JWT? Or maybe I have some small JWT and every time I need some special kind of info for any kind of microservice, I go and put it, or maybe grows a little bit this JWT or something like this, just not make it bigger.
Yeah, so I've seen two. That's a good question. I've seen two options for this. One which is a workaround. So with JWT, you can also zip the payload. So there is a way with some libraries to JZip the payload. And obviously, as we have a lot of characters which are the same, the JZip compression is going to be very efficient. I call it a workaround because that really doesn't, fix the problem. That fixed not the root cause, I would say, but the actual problem. The other option is really to do what we call an exchange. So the same way as you can exchange the username, password, and get back an access token, there is an RFC as well that you can use where you give the token you receive, which is probably a senior token, right, with the minimum information. And then you can get on the way back a bigger token where you have like additional claims or roles for your own call. Yeah. So I've used more the second one because that's more, in terms of architecture, I think that's cleaner. Instead of putting all the world into a token that then you need to really GZip so that it's not that big. So the second option is the one I would pick up. There is an RFC for that does the exchange. Another question? Yep.
What kind of technologies, methodologies actually do you use to break down and organize those microservices?
What kind of technologies?
Yes.
On the back end, I've seen like a lot of Spring Boot applications. I've seen also, so we do a lot of middleware and a lot of stuff around TomEE. So obviously most of our customers, they have their service like in TomEE, like the one I've built over here. So that's that's the two things I've seen basically in the past. Either way, Spring Boot or lightweight application server like Payara, TomEE, and some others.
Thanks.
Pessoal, última pergunta. Mais alguém? Dou-lhe uma.
But really, JWT is really universal. It's a JSON, and therefore, if you have Node.js, if you have Python, if you have whatever you use on the backend, doesn't really matter. There are a lot of libraries now that implement JWT, like for pretty much every language, Go, etc. So you can use anything you want, really.
Did you share the demo code in some place like website or GitHub?
The code?
Yeah.
Yeah, so the code is available on GitHub. So if you want to take a picture of the website, where is my mouse? So that's the GitHub repo. If you don't know how to find it, you can go to Tomitribe.io. Tomitribe.io is a small portal where we have like a lot of small libraries that you can pick and reuse on your applications. So in there is a couple of CDI extensions. There is some startup projects, and there is also this MicroProfile JWT movie fund. So when you click on it, you go basically to the GitHub repo. You get a couple of information. So if you don't know how to access it, you can go to tomitribe.io.
Pessoal, muito obrigado. Obrigado, Jean-Louis.
Thank you very much.